pragmatic architecture focusing on protecting the model. And I put this beautiful picture about how people defend what they care more about, right? Probably generally somewhere in between, somewhere that caring for what's really important, defending from anything which is outside. Now, let's see. Architecture. Software architecture refers to the fundamental structures of a software system. No. Architecture, in my opinion, is the stuff that matters. It's the stuff that's hard to change later. That are typical perceptions about what architecture of a system means. But my favorite is the art of drawing lines. I really like that. The art of seeing or of deciding what needs to be, what deserves to be separated, right? Drawing lines and then asking yourself, should I cross those boundaries or not? Now, this, if we don't do anything, by the way, this is a rare picture of a painting of a developer about his perception of how code looks. Right. This is what code looks if you don't do anything active about it. Right? It grows enormously into a huge mess. Before we continue, let me just have a few words about me. My name is Rentea. I'm a Java champion, coding since 2006. And what I do now for a living is basically trainings in all sorts of in many companies. Thousands of developers have been in my workshops. So this is what I am doing really today. I had to do a break in my training to come here with you, but my topics are Spring Hibernate, Java 8, architecture, clean code, unit testing. As I told you, my best part of it is clean code and design patterns. Then Java performance and reactive programming. This is basically what I do with teams around the world. And of course, as you can see today, I'm also taking part of all sorts of conferences and meetups like Let's Rock This Party, right? Right, now what can I do to help you is to come to your company, to have a little group of employees, let's say. You can join a masterclass like I do today with this time with Codecamp. I also have some video courses that you can get on my website, and the stuff that you can get just for free, there are past talks of mine. I also have a community, which is today one of the largest communities in Romania. It's over 3,000 developers, so if you care to join, I'll be happy to engage with you in any webinar that I do. I'm currently planning a new webinar about code smells, for example. So it's a lot of people in here, the vast majority from Romania, but we are speaking English, so yeah. Right, and I also have a little blog. In case you want to know more about me, I have a website and email and Twitter contact. Done. Good. Now, axiom. Do you know what axiom? Do you remember what axiom was? Axiom, something that shouldn't be demonstrated. Logic is simpler if implemented using data structures we control. Bang, like this one. What do I mean by that? Well, first thing, this logic that, our architecture, in my opinion, the most important goal of architecture, I'm a developer, right? I've been coding my whole life, so my first concern is survival in the code base, is writing an architecture that supports you in maintaining the code. Well, in my opinion, the most important goal of architecture is to allow you to implement your domain logic in the most simple, obvious, clean way. Any other goal of architecture, in my opinion, are collateral, are secondary. The most important thing is that the code remains readable and maintainable on the long term. So, in this regard, I would say that if you have supporting data structures, then your logic will be much easier. And I've seen countless examples in the groups that I do refactoring with in different companies. I take production examples from their code bases, and I see that if I just introduce several new objects, then suddenly the code becomes much easier to understand. Why? As a simple introduction, instead of passing around an object with 20 fields, if you make a little object just for the sake of that complex use case of yours, then that new object could have only 5 fields, not 20. And the code is more relaxed. If you see a method taking an object with 5 fields, you say, okay, that's okay. But if you see a method taking an object with 20 fields, oh my God, what the hell is going on in there, right? So you want focused objects that support your requirements, your logic. Then, if they are so small, you can actually make them even immutable, or you could add to them invariants. You can make them preserve different constraints of your model. You can make sure that the total amount in the order remains in sync with the sum of the order lines, or that the customer never gets a null name, stuff like that. You can make more aggressive constraints on smaller objects than you can on a 20 or 40 fields. And not the last thing, if you have smaller objects, you feel more comfortable of putting more logic in those, and that will make your central logic easier to understand, because the little pieces of logic that can be pushed into the little structures that surround you, you would put them inside, doing OOP, putting behavior next to state, making the code more readable, more self-explanatory. So these things, in my opinion, is something that you want to clean the logic. That's the ultimate goal, in my opinion, to make the logic as simple as, implement it as simple as possible. Right. And we will see 3 ways of doing that. The first way was the first discussion will be how to keep and why to keep the data transfer objects out, the stuff that comes from outside. Then, why and how should we extract value objects out of our existing entities? And if we get time, we will talk about how we can handle like a large monolith that has these entities that span different areas of logic, different business areas. What should we do about that? Because these are very large entities, so they become unreasonable very, very, very fast. So let's start at the beginning. Chapter 1. DTOs are evil. Now, let me explain. There are 2 kinds of DTOs attacking us. I wanted to start with this section because today more and more teams are doing microservices, more and more teams have to work with integrations with other systems. So we, almost any application we write will have DTOs sent and received from their client, maybe UI, maybe client, and also DTOs sent and received from third-party APIs. We will handle both, but we will start with these, with the DTOs that we have to work with from other systems that we invoke, okay? The DTOs that we receive from the APIs that we call from our code. Good. Before we even start, however, we have to make a distinction, very important distinction, between the kinds of APIs that we expose. Now, architecture is pretty difficult to explain because it can be so different based on what application profile you are building. For example, start with the one that you probably most know, APIs that are exposed to browsers. Like imagine an Angular application in front of that sending REST requests. And we will also talk about APIs to other systems, and also nano services. A new kid on the block, you will see what that is. First of all, if you expose DTOs, like objects, to a front end, right? The first, very easy, you will see the data structures that need to support rows in search forms, in search grids like that, that bring stuff from multiple entities. A row, imagine the JSON structure that needs to support this row. That will bring data from multiple entities. You could think of it like a random projection for the sake of the user interface. Right? This is just something that the user interface dictates. Right? All this beautiful flag in a JSON can be deleted by current user. Brilliant. What do you think frontend will do with this flag? Can be deleted by current user. It will toggle a button, right? Disable, enable a button. Or sending from backend the date formatted. This is something, I had valid reasons to do that sometimes. So these things demonstrate that the data structures that you send and receive from frontend are controlled by frontend. They dictate what you should put in there. Right? And that's a good reason that you should separate those from your domain model, from your internal domain model. You want to be able to, you will see, you want to be able to decouple domain entities from DTOs, from API models. However, there is a new kid on the block here with GraphQL, which would allow you, and I have some teams doing that are exposing a single API from which everyone takes their data, like querying exactly the fields that they need. Like you don't need anymore that much version on such an API because everyone can take what they need. It's tricky because then you don't really have a single API anymore. You kind of give up REST and you create like a flexible structure. If you don't know about that, read about that, especially if you're using mobile, if you're having mobile clients, or you just want to unify your APIs. Now, the APIs that you expose to other systems, they usually talk to them through some DTOs that are negotiated. You might have a little discussion. Should I give you that date? Or would you format it, or should I format it? Would you like me to fetch that for you, or would you fetch it yourself? These kind of negotiations should happen at the API level. Now, what the hell are nanoservices? Nanoservices, as the name tell, are like super small microservices, like 1,000 line of code. Maybe you can think of it like lambdas or cloud functions. And you might very well be in the case in which you have like a team of 5 developers maintaining 20 microservices, or 20 nano services. That's when you call them nano. Super tiny, focused services. Now, they are special in one sense, because you see, if you have this case, like 5 developers on 20 systems, it means that this team will collectively handle a set of systems. Now, why is it different? Because you see, you've heard of bounded contexts, probably. The idea of having a team sharing the same knowledge and understanding about words, and not only words, constraints, semantics, set of attributes. The team will have a shared understanding. Why? Because they talk to each other every day, right? So the team will share the same mind model of the concept. So in that particular special case, it is acceptable that the DTOs that you send from one nanoservice to another, as long as they are bound to the same bounded context, as long as they are handled by the same developers, it's reasonable to accept DTOs from other systems to enter your central logic here, maybe here also. It is acceptable to do that. Why? Because in the end, we are not defending from any different understanding from any external bounded context. In the end, we are sharing the understanding. Now, why am I telling this? Because I've seen teams very frustrated that they were mapping, so they had the entities here, they mapped to a DTO, and then they mapped once more to the entities in there. They did a lot of effort and they didn't understand why they were doing it. And in my opinion, you should not necessarily do that. Now, the game is completely different if you think about this interaction. When one calls a system which sits in another bounded context handled by another team, then that's a completely different beast. That's where that can be. That's where misunderstanding can happen. That's where different. That's where the bounded context happens. That's where the fight happens between your world and their world. So you will defend from DTOs. These enemies coming from here will be your enemy, not necessarily these from here. All right. So let's get this straight, and then let's see. The point that I'm trying to make here is that the data transfer objects that come from the outside world should be decoupled from your domain model. Now, that's an exception here also. In microservice ecosystems, I see more and more systems which are just boundary systems that talk to some external large external service. Imagine like a SAP or a Salesforce, or just a foreign API, like the French government. I don't know. When you integrate with such an API, there is a common practice to put a boundary system on the margin of your ecosystem, and then provide an API to which all of the others will consume data from. Now, this particular boundary system doesn't have any business logic of its own. It's just a huge adapter. It's a huge adapter system. In that case, this guy doesn't have a domain. Now, this is not a drama. I mean, they have very large challenges actually to see how they can best use the API they have to consume from the outside world, and to provide a nice generic API to the internal systems. But they themselves, they don't really have their own state management. They don't really have their own, usually, they don't persist stuff usually. Or if they do, it's just like temporarily or just store and forward. They don't have business, they don't have transitions, business logic to implement most of the time. So in that case, in that particular case, it doesn't really make sense to make this decoupling because there is no domain model. It's just DTOs from them and DTOs from us, and we convert. Very common, really integrating with machine learning, with all sorts of technologies. Now, you see, this decoupling over here has a price to pay. Like anything in our life, anything we gain, like this ability to change the domain without impacting our API, or vice versa, being able to change our API to our clients without impacting the model. This freedom that we have here comes with a price. The price is creating more classes and writing mappers. Now, we found a solution to avoid creating manually classes that look the same in different classes, in different systems, which is by means of generating the DTOs. probably by a Swagger gen. So in the case of a nano service, that's a very common scenario. You get like a YAML that is shared, and you generate the DTOs here, here, and here, right? But God forbid you propagate those from here. So generating data structures is a common approach these days. Now, even with mapping, we were smart enough, and we found automatic mappers. Imagine Mapstock, if you know it. This automatic mapper is actually able to convert to copy fields from this to this, maybe with some minor conversion, if as long as the field names match. As long as the field names match, you don't have to do anything explicitly. Of course, if the fields are different, you can work around it. There are some ways, but it gets very comfortable when the DTO and the entity are kept in sync, because the mapping happens automatically. You don't have to write any line of code. And this is actually the temptation with those automappers, because developers are inherently tempted to keep the models in sync. But do realize that we've created the DTOs in the first place exactly for them to be able to diverge from the entities, exactly to get the freedom to change in this. We create the DTOs in order for them to change. So resisting that change and keeping them in sync defeats the purpose. Then stop using DTOs if you like, and put JSON annotations on your entity. So the point of having two separate data structure models is exactly to allow them to diverge, right? So be careful about that. Never think, oh, let's update the other one, and perhaps we will be able to keep them in sync. That's not the goal. For sure, that's not the goal. That's the thing that I wanted to point here. All right. So automatic mappers, DTOs, and domain. Now, what's the catch? The trick here is that to put inside of your central domain whatever code you want to protect. Now, I know this sounds very fuzzy. I want to protect. What code I want to protect? Really not. The point is, in that domain, if you read any kind of literature, there should be the domain, services, and entities, right? Of course, if you are playing DDD card, then okay, aggregates, value objects, yeah, all right. But in my opinion, in that domain should be the things which matter most, the things that make your known NP. I don't say I'm not recommending Mapstruct. I'm saying that don't resist. I mean, allow the models to diverge, right? It's pretty reasonable to have the automapper working perfectly at the beginning of the project, but don't strive to keep it working after 2 years to make the same. Don't fall in the trap of keeping the models in sync. Allow them to diverge. That's why you created the two models in the end, initially, right? You want to allow them to be different. To give you an example, here in the map structure, imagine that you have like an entity, like customer entity, and then a customer DTO. Imagine that the customer entity, because it grew too big, you want to crack it into smaller pieces, and you will take parts of it and you will restructure the entity to shrink its size, to make it smaller, right? Now, that shouldn't mean that you should restructure the DTOs, right? You should not keep them in sync, nor should you vice versa. Like when the user interface wants some changes in a field name, or they want things to be a bit different, you to be updating the entity model. You should not be propagating changes from one side to another. And it is quite very often the case that you want to reduce the size of an entity and you restructure it using little value objects. And on the other end, the front end would like to keep their model flat usually. So don't resist this. I mean, don't resist this change. Allow it to happen, and then with maybe custom mappers, writing like get set. I mean, the kind of code that you write in a mapper is not killing you. It's super trivial. Yeah, it's a bit boring, I know. At the beginning of the project seems to be like monkey work, but really on the medium long term, you will see that this allows you flexibility into changing the models independently. That's why you created DTOs in the first place. Super, super important. Hope that helps. Now, folks, in case there are questions, as you do, fire them in the chat, or if you don't have the chance to ask them there, email them to me afterwards. So I will be happy to debate with you even afterwards. Good. Now,
there is one question. There is one question now. So you don't recommend Mapstruct
I've answered that.
Already.
Yeah, do use MapStruct, but don't be keen on keeping the fields in sync. And don't take it as a drama if after 6 months you give up MapStruct. It's not a problem, right? We had some performance issues with AutoMapper. We had to do the entity DTO conversion manually because that other one uses reflection. Not right. Not quite. MapStruct uses generated code. And you can also have problems with long-block annotation processor. That's just technical stuff. What I'm saying here is the conceptual. I want to make it very Java specific. Conceptually speaking, the DTOs and the entities should be able to change independently. All right. Now, imagine that you have this domain built with domain services and entities. And at some point from a domain service, you need to call some external service. Now, in any language, if you want to call a class, to use a class, you need to import the class. However, the very fact of calling an external API, in some cases, it gets a lot of garbage in your domain, pollute your domain, right? So don't call external APIs directly. If you're on Java, please imagine here Feign client or maybe a REST template or maybe, calling a REST API. Now, calling it directly from your domain makes your domain ugly, so we won't call it directly, but instead we will introduce an adapter to accommodate this garbage. And we will call the external service through an adapter. Now, what's the point? The point is that this adapter will do the conversions and has the opportunity to, will convert the DTOs that come from outside into some entities that we want to manipulate inside, into our own entities and value objects. Right. Now, if you put this adapter in an infrastructure module and you link it with the dependency like this, because you have to be able to see the adapter to call it, right? If you do that, then you run the risk that at some point in time, some careless developer, some just maybe was just tired. Some developer at some point might allow a DTO to enter the domain. Because you see, the domain sees all the infrastructure, the adapter, and also the DTOs. So they are visible in the domain. And at some point, you run the risk that a DTO might enter the domain. And you want to defend yourself from that. Why? Because you want to keep your domain isolated from any external agency. So what do? You apply dependency inversion, we call it. We extract an interface. Look what happens. We extract an interface from the adapter, and we pull the interface into the domain module. As you do that, the dependency direction just got inverted. Let me play that again for you. So we have the interface from the adapter, pulling it into the domain, and the dependency just got inverted. Why do we invert? Why do we have to invert it? Because now the adapter has to implement the interface. And because it needs to see the interface, the direction of the code dependency needs to go backwards. All right. Now, in words, it means that whenever in the domain you need something from outside, the first thing you do, you express your intention, your need in an interface that speaks your domain language, in your word, your terms. And only then you put on your gloves and you go in the infrastructure module and you implement the interface that you yourself have created previously. Right. What's a domain? Good question. Shawarma master. Excellent. It's a kind of shawarma, but yeah. Exactly. What's a domain? We can spend half a day discussing. I might actually agree. You might actually convince me that the domain is an infrastructural concern at some point. Because if that's the complexity of your system, if that's what makes your code harder to maintain, then that's your domain. It's tricky. It's hard to say it that short. It's a longer discussion than this. Just because those are okay. Good. So the point is the infrastructure will implement the contract dictated by the domain. Now, at runtime, of course, the domain will be able to call the adapter because what will be injected in the domain service over here, there will be injected the implementation automatically. So the dependency injection container, whatever you use, whatever language you use, will inject the implementation into that dependency over here. So at runtime, you will get to call the infrastructure, but without depending any code from it to it. We call this the dependency inversion principle. It's the D in the story. And in my opinion, the second after S in importance. So the dependency inversion principle tells that abstractions, higher level policy should not depend on miserable details like networking, files, or even data structures, maybe not Not even. The worst thing you could do is to depend on DTOs from outside. Now, this basically inverting the dependencies like this allows you to have your domain completely isolated from the lower level. You can't see anything. If you control space over here, you won't see any class from the lower level module. This is the magic of dependency inversion. It's fascinating, and that's why Uncle Bob says that's the best thing that OOP gives you. Right? It's really, really powerful technique. And this dependency inversion you can apply however you integrate with external systems. However you start, whatever integration you have to start, whatever paradigm you're using, queues, files, database, or synchronous stuff, whatever you do, you can use dependency inversion to make sure that the data structures from outside are not visible or accessible in the domain, are kept safe, away from the domain. Interesting. This is one way to do this, to stop the classes in that infrastructure to enter the domain by using the compiler. Because if you follow the links over here, if that POM, let's speak Java, depends on this POM, then there is no way that in this module you can see the stuff in the other. Right? I do need to explain myself. I feel you might not get why am I so angry with DTOs from outer worlds. Right? I've seen code. I had a big client in the gaming sector, and they were receiving the inventory of items of the player. And my God, an item, like imagine like an X, right? An X had 40 attributes, and they were doing heavy logic on those items. But if after 1 hour of exploring the code, I realized that they were actually only using 3 attributes or 4 from those 40. So every time, however, I was stumbling upon some DTOs that were coming from the inventory microservice, right, with 40 fields in my microservice here. Right? And I kept struggling to understand why are there so many fields? And not to mention that the DTOs, of course, because they were so big, they were generated using Swagger. You can't really, I couldn't ever put any kind of logic inside those DTOs. After 1 hour, I realized that, and I started creating little objects in which I extracted the stuff that I really needed from the inventory item. What I ended up with classes of 5, 3, 7 attributes, and then I was able to push the logic that I had operating on those fields to push the logic in the entities themselves, cleaning up the main flow, making it sharp and clear what the hell was going on in the main use case. How? By pushing logic down. So there's an advantage again. More comfort because there are less fields. You can even enforce constraints. You can actually make those objects immutable. They also had a problem with changing fields in weird places, and then you can put logic in that. So that's why I want you to write logic only on structures that you control. Right? We can make sure that we are not affected by DTOs from outside by using dependency inversion and letting the compiler fail the compilation if you're trying to use a DTO in the domain. But there is a lightweight version that you could also use. It's called ArcUnit in Java. In C# it's called ndepend. It's a library that can check dependencies between packages. So let me read this for you. No classes that reside in a package domain should depend on classes that reside in a package infrastructure. Ooh la la. And you know what? This runs on Jenkins and fails on Jenkins. Now, why am I showing you this? Because in a micro nano service, it's a bit overkill, maybe to make 2 modules and to invert. You could think of using such a strategy. Of course, it's not as powerful, as sharp, as visible as 2 modules with dependency inverted, but it's a nice startup for a small application. Okay, and of course, if you have a legacy big one, don't go for this. It's better to stick to something very sharp, very clear, that every developer understands. Right? The end goal is to have a domain that doesn't have anything to do with any external world, right? Or focusing on your logic, because your logic is complex enough. You don't want to be mixing your logic with integration behavior with other systems, with protocols, with weird rules. No, keep your logic focused on your stuff. So let's build this all together. We have this domain and we have the external API that you have to call. Now you call it using DT because they are bringing you DTOs, you want to defend from those, and you will employ dependency inversion over here to call them through an adapter that you put in a separate module. Right. But then there is also the other enemy, your client. Be it your front end, be it the applications that you call you. These also give you DTOs that don't necessarily match your entities, that, as I told you, will eventually diverge at some point. So that's the point. That's why you created those. So you have to map them, of course. And what I will do, if you Google about my talks, you will see something that explains more detail what's here. But the point is, there is a controller always, and then in my case, I introduce a facade. Like it's the only object with logic that is allowed to touch DTOs. But this is very thin. This I always keep very thin, and any kind of logic grows there, I will drag it into the domain service. Why? Because whatever crosses this boundary can never depend on a DTO. Why? Because my application will depend on the domain, like this, of course, because I need to call the domain service. So you see, if I had imagine some method in here which is complex, if this grows big, I will drag this from here into a domain service. Okay, then what happens? Because it is in the domain, it can never ever access DTOs. So you see what happens? Whatever logic gets complex, when it's extracted to the domain, it must be written only based on my own terms, entity and value objects or aggregates. All right, now this effectively blocks anything external to enter my domain. Nothing can get in. Now, there is an interesting discussion about database, whether or not you should apply the same technique to invert the dependency and to talk to the database in a secretive way, to basically shield completely the domain from the existence of the database. Now, this only makes sense if you construct a separate persistence model. Less than 5% of the teams that I train and consult these days, and I'm seeing hundreds of teams. The point is that if the database that you have here, the schema, is very, very ugly, you don't want to model your entities based on those. So you might introduce a separate data structure set. So then you will have 3 DTOs, domain model, domain entities, DTOs, entities, and this. I don't think that's a very good decision for most projects. But if you consider doing that, or maybe there is a very legacy database over there, do it, and you can use the same technique to make sure nothing from here ever gets in. Same idea as here, basically. But that's a very sad world to live in, really, to not being able to trust and be a friend with your database. Right, this is where we reached the famous onion architecture, right? The point of this is that all the dependencies from the modules around are pointing towards the domain. The domain doesn't know anything about the external world. Now, let me convert this to a pragmatic architecture. What I will do first thing of all, I will cut out this persistence model. Then I will use here a framework that allows me to generate the queries automatically based on my entity model, such as Spring Data, if you're using Hibernate or Mongo or whatever. And that basically cuts out the need of having a repository module. And then secondly, I will merge everything in a single module. And I call this the pragmatic onion. I've built applications medium large with this approach with no problem. We actually sit together after 3 years of development, asking ourselves if we should cut this and this. The unanimous answer was no. We were never, we didn't have any problems if we put these all in the same module. But we did wanted to keep the separation between whatever is outside of the domain and the holy domain. Okay, good. Now, if you read about clean architecture or onion architecture, it has many names. Right? It goes in the history every 5 years. Some smart one. Guess what? Guess how Uncle Bob called it. Right? The point is that this onion architecture has some goals. The goals are to keep your core logic independent of user interface. Right? That's why we create those DTOs in between. We want to allow them to evolve independently. Independent of database, you shouldn't put logic in there. Right? You shouldn't use features which are specific to Oracle or whatever. Then you shouldn't be dependent on external APIs because these have a different semantic set and they can change without notice. And very important for the domain to be able to test it simply with very little steps. Right? Can you write code as you would always are doing in a mock example? What? Can you code as you always are doing in a mock example? beats me, but I'm not sure what you're saying. But Marin, ask again, please. So here, the other thing that you can read about clean architecture is that it should not you should not depend on intrusive frameworks. Now, whether or not Hibernate or entity framework or entity entity manager is intrusive or not, that's a debate for another day. But as you can suspect from my case, my answer is no. If you know how to use Hibernate, it's not invasive, but you have to learn features which are not, let's say, largely known. Good. Coming back to the point. So logic is simpler because the structure that if you control the structures, you can make them smaller, immutable, valid, null safe, and maybe with business logic inside helping you. Now let's see the next chapter, extracting value objects. I searched for a quattro stagioni pizza here why? Because this particular slice of pizza makes sense. So does this. You see, although they're a part of a whole, these if you know quattro stagioni, it has four parts. So this is as you can see, the olives part. So we extract the value objects from entities. Now, please sit down, lay back on your chair, and tell me about that big entity of yours. Every medium-large project has a big entity somewhere. Tell me, how big is it? How many fields? Then tell me, can you make it immutable? So we realized we forgot about DTOs. We're talking about your entities. Can you make those entities immutable? If you think of it, you might start to scream. What? No, it has 80 fields. How the heck can I make it? Of course you can't make it immutable. Plus the fact that there is Hibernate around. Yeah, interesting thing. By the way, you could trick Hibernate to some extent. I have some videos on my YouTube channel in which I show how you can trick him to build effectively immutable entities, as I told them. But then, how do you feel about putting logic inside? And I had teams that tell me, what? I would never put stuff in customer entity. Why? Because it has 40 lines of code. I understand that you don't want to make it even larger. So then, tell me, how about extracting parts of it out? How about extracting groups of fields in value objects? Now, value objects are basically grouping of data, nothing more. They don't have an ID, and they don't mean you should change the database schema. No, the tables remain the same, but the way you model it in Java, in your code, is different. You can do this with any framework, entity framework in C# or GPA in Java. What do you gain from it? Well, then you can actually even try to almost make them immutable. It's really doable. It starts to be doable. And you will feel much more comfortable in putting logic inside with the same idea that it will simplify your core flow, right? Yeah, I know, Marin. Let's see if I can do that. Hibernate is not okay with immutable entities, but you can almost. I know, I agree with you. Hibernate is not okay with immutable entities by the book. But there are tricks you can do, especially about these embeddables. If you know what I mean with embeddables, you can do tricks in there. So these things suddenly become possible, right? Now, but how do we identify value objects? I feel guilty. Marin asked, could I show some code like I usually do? Now, Marin, this is an architectural discussion. I'm not sure if I am okay. I will try. But architecture, right? Not necessarily Java. How do we identify value objects? That's a really hard problem in many projects, because those fields sometimes don't group naturally. But there are some obvious ways you can identify them. First of all, if they really represent a conceptual whole, like a concept, like money, that's a classical example. But that could be not only money, but maybe stuff that doesn't have meaning one without the other, like address. Bang, that's your address. Or billing info. It doesn't make sense to have a VAT country without a VAT code, for example. So, then if these value objects, you can identify them because they change together. So the typical example is these two columns, left modified by, left modified when. These are always changed together. So why not grouping them together in a little value object? Screens also. If you have like a huge wizard or something like that, and you have different sections, different screens, different steps, then you can make value objects out of those, guiding yourself by the user interface. Really. Then also, if you see some fields moving together in many layers in many places, you could be kind and build them a home and name them somehow. Usually you don't get very smart names in here, but it can really help. Now, chapter 3, I thought to make it fast because I'm kind of running out of time. The confused entity. Now, here is a very interesting question. What's bad with the legacy code? Those of you who are working on legacy code will think, oh shit, where do I stop? But the reality, I've been in legacy code, like 2.5 million lines of code. Imagine this one, millions, right? What's bad with legacy code? First of all, in that project, of course, they were using some coding style from 20 years ago, from 15 years ago, old style and old frameworks. That in itself, it doesn't feel geek, yes, doesn't feel fresh, I know. But it also has like a very real problem that the code we used to write for the same problem 5 years, 10 years ago, it's twice the size. Now we write much more focused code because the frameworks evolved, the language features evolved. Have you seen what Java 17 will bring? Have you seen that they were adding as experimental, but this is Java. Switches, pattern matching on switches. So languages evolve, right? Then also there is a huge code that you, poor soul, don't know. So you have to read and understand huge code that you didn't write. And the last thing, there is excessive coupling. There are other reasons, but these actually, from this picture, these two really kill you. Having to understand code that you never ever read and is so huge, and having bugs because changes that you do ripple into parts that you never had a clue about. These two coupled together make legacy code so difficult. So how can we do about it? What can we do about it? So imagine that we could draw a line, the art of drawing lines, between two subdomains. Probably you've heard about this idea. You can try to identify two parts of the monolith which do different things. In some particular examples, you might find different dramatic differences in understanding about what a concept means. But definitely if you have a product that is used both here and here, that product will be huge for sure. So what you could do about it, because this is about data structures, what you could do is to try to create different data structures, one here and one here. That would cause people to question, what the hell are you doing? Why do you have two products in the same monolith? Folks, I'm talking about the monolith. Probably I suspect less than 10% of you will be in this section, But the point is, this kind of huge monolith, big 5, 7, 10 years old monolith, will definitely have a huge entity somewhere, which could be cloned, and keeping the fields which are specific to each part in isolation. Now, that would be also accompanied with, this line that you want to draw between the two parts of the monolith should be made explicit by introducing clear, sharp objects and events that can move across the boundary. Now, the point is that while you identify these connection points, you would find those that shouldn't be there first. And secondly, in the end, you might have developers which specialize in this part, though other developers that specialize in this part. And then the only connection they will have is through this line, this boundary. So what do you do about it? Well, you could imagine, if you have to change a part of the code, and someone knowledgeable about the code here doesn't really necessarily have to cross this boundary, right? Just like you would do in case those were microservices. So you don't need to pay the high price of distributed systems to get decoupling. That's what I keep saying in most of my talks. Try to modularize your monolith if you have one, right? And then maybe tomorrow, maybe in 10 years, maybe in 3 years, maybe this boundary will grow so thick and so obvious, then you can actually cut it out and make it a microservice. Who knows? But you start by decoupling the code. I think I'm running out of time. So as a recap, what I did, logic is simpler on smaller structures, on immutable structures, on safe structures, structures that can guard some rules in their state. And objects that can have behavior inside. It cleans up the main flow. And I would love to show you also code, but I'm afraid that would kind of, until you understand the sample, it's I'll be quite late, and I will impact the schedule. So then the objects don't have an ID. Thank you, Alexandra. But really, I'm not saying that those embeddables over here. I mean, how could I put this? I think you mentioned. I think you referred to this side probably. So ID, they don't have ID indeed, and because of that, they are persisted in the same table of the blue entity. So in the blue entity, there will be like these set of columns for this, these set of columns for this. This is what embeddable is doing. And I told you, there are some features in the object relational mapper that you have to learn if you really want to limit the design impact of Hibernate on your model. I know, Marin, but not enough time for today. Sorry. I think I am kind of done. So if you have other questions, please reach me out. I would really reach out to me. I would really be happy to talk more with you, to debate, because this is what I believe in. This is what I've done in 7 projects. This is what I'm discussing with teams all around. So if there's something wrong with what I say, I need to find out. Okay? These are my contact details. And again, I thank you very much for inviting.
Thank you, Victor.
Yeah.
So maybe this time you'll tell me your secret, where that energy comes from.
By the my secret is that I suck my energy from my trainees, but don't tell them. When I see people enthusiastic about, and they are all trying to learn and this attitude of a continuous learner, this is what it does to you. This is what it does.
That's the result, huh?
This is the result. Yes. I have a question for Albert.
Yes.
Where would you put non-trivial? Okay, thank you. Non-trivial validation logic, stuff that you can't cover with annotations on the DTOs in facade, service, or value object. Excellent. Stuff that you can't cover with annotations. Stuff that I can't cover with annotation. Oh, this is a Java question. Being a Java question, I should answer in Java. First of all, please know about, and here is the code. Design pattern, yes, design pattern is good enough. Let me see if I have it here. No, yes. Please be aware of this before you say that it can't be done with annotation. Groups, validation groups. You can have like validations that are enabled when the entity is in a certain state. It's a bit tricky to explain that fast, but you can imagine like the username can never be null, if it is submitted. However, it is acceptable to be null if it is in draft state. So it is like state depending validation. Know that first, and then if you still can't do it with annotations, I would do it in the facade. That's what I've done, and it looks good there at the beginning of the flow. So from the controller, you call into the facade in my architecture, and then the first thing in the facade you map, and then you validate, or you validate, then you map, depending on the case. But there at the beginning, and whatever gets complex, only then you go into the domain. Maybe it helps. I know it's very short. The uniqueness of the email. Excellent. It depends whether you are in a monolith or a distributed system. I mean, in other words, it depends whether your business starts crying when you mention eventual consistency. If you say eventual consistency and they start screaming, then you are in deep smelly problem. In that case, you want to check that at the beginning in a transactional way. So to make sure that the data remains valid, probably with a unique key in the database, right? If you went to microservices, and it's kind of the same question. If you went to microservices in a distributed system in particular, then you have already had contact probably with the eventual consistency. If you send the message on a queue, that will take some while to get the other part. And then what we can do, classical, and that's indeed one of the biggest problems with distributed systems, to tolerate for stale data, inconsistent data. If that's a drama, make automatic recovery. If that's not a drama, wait for the event to bring you the update. Oh, the email changed. But this is a problem that you need to explain also to the users, and that might make it difficult for them to understand. That's the price to pay if you go microservices. if you stopped at a well decoupled monolith, you don't have to pay that price, because you can still have a unique constraint on the product from the or in your case was a customer email. That's the price to pay for distributing your code in different systems. And if you know the CAP theory, that I would say that only sacrifice consistency if you really want performance. Otherwise, what are you doing? You're just chasing a dream, a hype. So I think that's
Victor. Thank you so much, everyone. If you've got more questions for Victor, you know how to find him, right? So Victor, where do we find you?
Yes, let me put my contact slide again. Email is there, is the fastest way, but you can also tweet me if you want to make it more of a debate. And I also have a site in case you want more stuff about me.
Rentea.ro.
I didn't talk about aggregate. I didn't want to make a DDD talk. That's a different beast.
That's for the next.
For the next.
Okay. Okay, let's keep it for that.